Q6649. When the pilot leans the mixture control, what is being accomplished? A. The volume of air entering the carburetor is being reduced. B. The volume of air entering the carburetor is being increased. C. The amount of fuel entering the combustion chamber is being reduced. The correct answer is C. When the mixture control is leaned, the fuel flow is decreased, resulting in a leaner mixture. A leaner mixture contains less fuel relative to the amount of air entering the combustion chamber. By reducing the amount of fuel in the mixture, the pilot ensures that the air/fuel ratio is optimized for efficient combustion. This adjustment is necessary in various situations, such as cruising at higher altitudes, where the air density is lower. Leaning the mixture helps prevent fuel wastage, improves fuel efficiency, and promotes smoother engine operation. It also helps to prevent the fouling of spark plugs and reduces the risk of detonation or pre-ignition, which can occur with excessively rich mixtures. 6650. The main purpose of the mixture control is to A. Increase the air supply to the engine. B. Adjust the fuel flow to obtain the proper air/fuel ratio. C. Decrease the fuel supply to the engine as the aircraft descends. The correct answer is B. The air/fuel ratio refers to the proportion of air to fuel in the combustion mixture. For efficient combustion, a specific air/fuel ratio is required based on the engine design and operating conditions. The role of the mixture control is to adjust the fuel flow to ensure that the air/fuel ratio is within the desired range. By manipulating the mixture control, the pilot can either enrich, increase the fuel content, or lean, decrease the fuel content, the mixture. During different phases of flight, such as takeoff, climb, cruise, and descent, the pilot may need to adjust the mixture control to maintain the proper air/fuel ratio. For example, during climb and cruise, leaning the mixture is often necessary to compensate for the decrease in air density at higher altitudes. Proper adjustment of the mixture control is crucial for optimizing engine performance, fuel efficiency, and preventing issues such as fouled spark plugs or detonation. The pilot must refer to the aircraft's operating manual or follow specific procedures provided by the manufacturer to ensure the appropriate mixture adjustments based on the prevailing conditions. 7242. The uncontrolled firing of the fuel/air charge in advance of normal spark ignition is known as A. Instantaneous combustion. B. Detonation. C. Pre-ignition. The correct answer is C. Pre-ignition refers to the uncontrolled firing of the fuel/air charge in an internal combustion engine before the normal spark ignition event. It occurs when the air/fuel mixture ignites spontaneously due to factors other than the spark plug firing. This premature ignition can cause a variety of issues and can be detrimental to the engine's performance and reliability. Pre-ignition can be caused by several factors, including hot spots in the combustion chamber, carbon deposits on the spark plugs, overheating of the engine, or the use of low-quality fuel with low octane ratings. These factors can create conditions that lead to the fuel/air mixture igniting prematurely, often causing a knocking or pinging sound. When pre-ignition occurs, it disrupts the normal combustion process and can lead to a decrease in engine power, increased fuel consumption, and potentially damage to the engine components. It is important to address pre-ignition issues promptly to avoid long-term damage to the engine. To prevent pre-ignition, it is essential to use the recommended fuel with the correct octane rating for the engine. Regular maintenance, including cleaning or replacing spark plugs, monitoring engine temperature, and ensuring proper cooling system function, can also help prevent pre-ignition. Additionally, avoiding aggressive driving or heavy loads on the engine can help reduce the risk of pre-ignition events. In summary, pre-ignition is the uncontrolled firing of the fuel/air charge before the normal spark ignition event in an internal combustion engine. It can cause performance issues and potential engine damage, and preventative measures such as using the correct fuel and proper engine maintenance should be taken to mitigate the risk of pre-ignition. 7243. The uncontrolled firing of the fuel/air charge in advance of normal spark ignition is known as A. Combustion, B. Pre-ignition, C. Detonation. The correct answer is B. Pre-ignition can cause a host of problems within the engine. When the fuel/air mixture ignites prematurely, it creates a second ignition source that collides with the flame front initiated by the spark plug. This collision can lead to a rapid increase in cylinder pressure, resulting in a knocking or pinging sound. The increased pressure and temperature can cause engine damage, including broken spark plugs, bent valves, and even piston failure. The main reason behind pre-ignition is the presence of a hot spot within the combustion chamber. Hot spots can be caused by various factors, such as overheating due to an excessively lean fuel/air mixture, localized overheating of the spark plug electrode, or the accumulation of deposits on the piston crown or cylinder walls. Additionally, certain contaminants, such as carbon deposits or metallic particles, can act as hot spots and initiate the premature combustion of the fuel/air mixture. To prevent pre-ignition, it is crucial to maintain proper engine operating conditions and combustion chamber cleanliness. This includes using the recommended fuel octane rating, avoiding excessively lean fuel/air mixtures, and ensuring the cooling system is functioning effectively. Regular maintenance, such as cleaning or replacing spark plugs and addressing carbon buildup, can also help mitigate the risk of pre-ignition. In summary, pre-ignition refers to the uncontrolled ignition of the fuel/air mixture before the spark plug fires in an internal combustion engine. It can lead to knocking, increased cylinder pressure, and potential engine damage. Maintaining proper operating conditions and addressing potential hot spots and contaminants are essential to prevent pre-ignition and ensure optimal engine performance. 6651. Proper mixture control and better economy in the operation of a fuel-injected engine can be achieved best by use of A. A fuel flow gauge, B. An exhaust gas temperature indicator, C. The recommended manifold and RPM setting for a particular altitude. The correct answer is B. An EGT indicator measures the temperature of the exhaust gases exiting the engine's cylinders. By monitoring the EGT, pilots and operators can obtain valuable information about the engine's combustion efficiency and fuel mixture. Here's how an EGT indicator helps achieve proper mixture control and better economy. 1. Mixture control. The EGT indicator allows the pilot or operator to optimize the fuel mixture by adjusting the air-to-fuel ratio. The goal is to achieve the ideal stoichiometric ratio, the chemically balanced ratio of air and fuel, for efficient combustion. By monitoring the EGT, the operator can fine-tune the mixture to reach peak EGT, indicating the most efficient combustion process. This process is known as leaning the mixture. 2. Fuel efficiency. Achieving the proper mixture control results in improved fuel efficiency. When the air-to-fuel ratio is optimized, the engine burns fuel more effectively, extracting more energy from each unit of fuel consumed. This efficiency leads to better fuel economy and reduced fuel consumption, resulting in cost savings. 3. Engine health. Monitoring the EGT helps in detecting and preventing potentially damaging conditions. A high EGT can indicate a lean mixture, which can lead to overheating and potential engine damage. Conversely, a low EGT may suggest a rich mixture, leading to incomplete combustion and wasted fuel. By maintaining the EGT within the recommended range, operators can ensure the engine operates within safe and efficient parameters. 4. Altitude compensation. The recommended manifold pressure and RPM settings for a particular altitude are important for overall engine performance, but they do not specifically address mixture control. An EGT indicator provides real-time feedback on the combustion process and allows for adjustments regardless of altitude. It helps compensate for changes in air density at different altitudes, ensuring the optimal air-to-fuel ratio is maintained. In summary, an exhaust gas temperature, EGT, indicator is the most effective tool for achieving proper mixture control and better economy in a fuel-injected engine. It allows operators to optimize the air-to-fuel ratio, improve fuel efficiency, maintain engine health, and compensate for altitude variations. Monitoring and adjusting the mixture based on EGT readings result in efficient combustion, reduced fuel consumption, and cost savings.